Hello, Algebra 2. This is a quick review of composition. If you were struggling with composition a little bit throughout the first couple units, we are going to review the 3 different ways that we have used composition so far this year. You will see it again several times throughout the year, so let's make sure we've got it now, and this video is trying to help you do that. If you guys notice, the very first way that we did composition was using a real number. And I'm going to go ahead and set up a function, and then another function that just happens to be a constant. So it's going to be just a real number that we're going to use. So for example, if you guys are given that f of x is 3x squared minus 5. You're also given that g of x, again, g of x and f of x are just 2 different names for one function. So it doesn't matter what we call them. But g of x is just going to be -1. What you're asked to do is you're asked to find f of g of x. If you notice where g of x is inside of f. It's inside the parentheses. So I'm going to go over this g of x in red so that everything we do with g is in red and everything with f is in blue. Since f is on the outside, I'm looking right here where this f is. I am going to write down what my f is, but I'm going to replace the domain with parentheses because I know I'm going to replace my x value. So I'm going to look at f. f is 3 multiplied by x raised to the second power minus 5. I left parentheses there because composition, the definition, is when you replace a domain with a range. In other words, you're replacing an x with a y, or you're replacing the x, which is the domain, with what the output is, which is the y, or whatever the function is. So if I look inside the parentheses, I want to put g of x inside the parentheses, which is right here. So I'm going to put that inside the parentheses because that's what my range is. G of x is equal to -1. So all I need to do is put -1 inside the parentheses. At this point, I am ready to simplify. We are simplifying. Anytime you simplify, you are following the order of operations. So we are going to simplify using PEMDAS. Okay? Simplify with PEMDAS. So PEMDAS starts with parentheses and then exponent. Well, I have parentheses and I have an exponent. So I'm only looking at what is inside the parentheses and I'm only looking at where the exponent is. So my exponent happens to be outside of the parentheses where the -1 is, which means my 3 stays the same. I have something happening here. My -5 stays the same. -1 squared, I'm going to replace with +1 because -1 squared is -1 multiplied by -1. So I get +1. Now that I've done parentheses and exponents, I can move on to multiplication or division. I do not have any division in this problem. I only have multiplication. So again, when you see a number and there's nothing in between the number and the parentheses, that means that I am going to multiply. So 3 multiplied by 1 is 3. And now I can subtract 5. I'm now at the point where I can add or subtract. So 3 minus 5 gives me -2. What I just found is, I'm going to write my answer over to the side. What I just found is that in this example, my f of g of x is equal to -2. That's my final answer because I replaced g as the domain in f. This works with any function that f and g happen to be. So I'm going to make them just a little bit more complicated, and I'm going to make them 2 other different functions, not a constant, not just a number like -1. So I'm going to say, let's say that we were given the same f of x, 3x squared minus 5. Ooh, funny 5. Instead of being g, because g already has a definition, I'm going to say h is another function. Let's get rid of that there. And let's say h is 2x. Let's say negative 2x plus 1. What I'd like to find is, let's do f of h. Another way to write f of h is by using the parentheses and the small circle. This is not a multiplication circle. It means of. F of h. In other words, it's telling you to use composition. F of h is the same thing as f and then put h inside of f. Again, I'm going to try to outline that with, Smartboard has jumped. I'll rewrite that in red just so you guys can follow. F of h of x. Okay. So all I'm going to do is now replace the domain of my f, which is the x value in my f function, with my h, because that's what I'd like to do here. So let's try this. Let's take my f function, which is 3x, so I'm going to use parentheses, squared, minus 5. Last time we replaced the x with negative 1 because that's what my function was, the g function that I wanted to put inside of f. Now I'd like to replace the inside, the h, with what my h function is, and that is negative 2x plus 1. Gotta squeeze it in there. Okay, so if I'm placing negative 2x plus 1 squared inside of my f function, I'm going to give ourselves a little bit of space here. There we go. Again, I am now ready to simplify. When I simplify, again, I'm going to use the same order. Same order. So my same order is going to be to look at my parentheses and my exponent first. That means that I'm going to come this way a little bit so I have a little bit more space. The 3 does not change. Something will happen with my negative 2x plus 1 squared, and then minus 5. If you guys remember from our factoring unit, when you have negative 2x plus 1 squared, we need to use FOIL. Negative 2x plus 1 squared, we need to use FOIL. So I'm going to come over here on the side. I'm going to do some work. And I'm going to say, okay, negative 2x plus 1 squared means negative 2x plus 1 times negative 2x plus 1. Oh, wait, there we go. Fit it in. So let's use FOIL. Negative 2x multiplied by negative 2x gives me 4x squared. Negative 2x multiplied by positive 1 gives me negative 2x. And then 1 times negative 2x gives me another negative 2x. And then 1 times 1 gives me positive 1. I can combine a couple like terms. So I have 4x squared. Negative 2x and negative 2x gives me negative 4x. And then I also have the positive 1. Okay? Now if you guys look back at the earlier example we did, this was the time when we multiplied the 3 times the 1. Well, I'm multiplying 3 times everything that's inside the parentheses. Earlier, 1 was the only part that was inside parentheses. So now I have to distribute it to all 3 of the terms, 4x squared minus 4x plus 1, inside the parentheses. So let's try that. I now have 12x squared, negative 12x, positive 3, and now I want to subtract 5. If I think about simplifying, my last step would be to add or subtract. So I'm looking for common terms that I can actually add and subtract. The only common terms I see are the positive 3 and the negative 5. So my final answer would be 12x squared minus 12x, and then 3 minus 5 is negative 2. For this problem, that is my final answer. Last but not least, the last concept that we learned with composition is how to verify that two functions are inverses of each other. So let's say you guys are given you have one function, which is f of x, and you're told that f of x is 2x plus 7. And then you're also told that the inverse, so remember that little -1 exponent means inverse. You're told that the inverse is supposed to be x minus 7 divided by 2. Well, that's great, except what I'm really looking for here is, are these actually inverses of each other? Let me verify that these are actually inverses of each other. If they really are inverses of each other, then what I can do is use composition. And to use composition, I'm going to take f of the inverse, and I'm also going to take the inverse composed with the original. I'm going to put the inverse inside of the original, and then I'm going to put the original inside of the inverse and hope that I get x in both of these cases. So let's try this one. I'm going to start with f because that's on the outside. F is 2x plus 7. The x is being replaced with the inverse that is on the inside. So I'm going to take the x minus 7 and divide by 2. That goes inside the parentheses, and I'm hoping that it will simplify to give me what I want. So let's try this. If I distribute this 2 inside the parentheses, and I also keep the 2 as a denominator, I will get 2x divided by 2. I will get minus 14 divided by 2. And then I have this random 7 added on at the end. Okay? If I come over to the right and I do the exact same thing, but I start with the inverse. My inverse is x minus 7 divided by 2. Remember that this x is being replaced with what's on the inside, which is the original f of x. The original f of x is 2x plus 7. Our smartboard is wonky, but that's okay. So now my job is to simplify. If I simplify both of these, let's take a look over on the left-hand side again. 2x divided by 2 will just be x. 14 divided by 2 is 7. Therefore, negative 7 plus 7 is 0. And all I have left is just x. There's my final answer. If I come over to the right-hand side, what I'm looking at is, well, I'm doing 2x plus 7 and then minus 7. 2x plus 7 and minus 7, the plus 7 and the minus 7 will cancel, so I'll have 2x divided by 2. 2x divided by 2 is the same thing as x. Again, I got x. X is what I wanted in both cases. If I get x when I do both compositions, when I do the original inside of the inverse and the inverse inside of the original, if I do that and I get x both times, I have verified that these were correctly given to me. They were actually inverses of each other.